We are looking at a Newton's ring apparatus. This apparatus is constructed with a piece of curved glass that makes contact with a piece of straight glass. There's a thin film of air in between the contact surfaces. And due to refraction and reflection of the yellow light that enters the curved glass, the Newton's rings are formed. What we are going to do today is we are going to use an equation to determine the radius of curvature of the curved glass. If you can see, I am looking through the aperture, and here you see the yellow light, and indeed you can see Newton's rings displayed. This is the glass that I was referring to, the curve that makes contact with the straight glass. We're going to use this microscope here to measure actually the radius of the 7th ring and then the radius of the 14th ring. And then we'll do some calculations to determine the radius of curvature of the glass. Above is a diagram of what you would see in the eyepiece of the microscope. You'll see many concentric rings. We are interested in the radius of the 7th and the 14th. We will give you the data. Below is the equation that you will use to determine the radius of curvature of the upper piece of glass. So you'll be using this equation. The equation is S14 squared minus S7 squared, and that is the radius of the 14th ring minus the radius of the 7th ring, both are squared, divided by the radius of curvature of the glass piece, that is the term you are solving for, is going to equal order number 14 minus order number 7, which is just 14 minus 7, times the wavelength of the yellow light. We've taken the data for you. The equation you will be using is above, and so the data you will be needing is the radius of the 14th ring is 0.4449 times 10 to the negative 2 meters divided by 2. The radius of the 7th ring is 0.3740 times 10 to the negative 2 meters divided by 2. And the wavelength of yellow light is 589.3 nanometers. And with all these data points, you'll be able to solve for the radius of curvature of the glass. You are looking at a diagram of actually what you're looking at, the Newton's rings. You have what's occurring here is constructive and destructive interference. The dark areas that you saw when you look through the optical piece of the microscope were actually destructive, and the light areas are constructive. So we have incident light upon the curved glass. Some gets reflected from the surface of the curved glass. Some gets refracted through the air and reflected from the surface of the glass on the bottom, and thus causing the Newton's rings effect.